Statisticians will plot data as points on some kind of graph and then ask, is there some trend to this data? And do you see a pattern? Well, the term trend line is an estimation of the pattern, and it uses a linear function to estimate it. And so I could look at this data and ask, well, or say that to me it looks like there is a pattern here. It goes something like that. I'm just drawing some kind of line out there. Of course, the equation of this line is going to be hard to find because I don't know any specific points on there. I just drew it, out of the blue. But we can ask, well, if we find 2 points in this data set and draw a line through those 2 points, then we can find the exact equation of that line. So in this case, we can ask, well, if we have 0.86, 86 is right here. Throw a dot there. And then 12.7 is right there. And then draw a line between those 2 points. We can ask, what's the equation of this line? So that was my estimation of what that line looks like. So the equation of this trend line, the function, this is going to be, we're going to use the point slope form to find it. We need to have the slope, of course. I'll name this x1, y1, x2, y2, slope, y2 minus y1 over x2 is 12 minus x1 is 8. It's going to be 1 over 4. And y minus y1 is 6 equals m. X minus x1 is 8. That's the point slope form of a line. Solve it for y to get the slope intercept form. Y minus 6 equals 1/4 x minus 2. Add 6. We get y equal to 1/4 x plus 4. And I'm very close to this. This was actually, let me see if I can draw a little bit better. It goes through this point. It looks like it goes through that one as well. That's that thing. The slope of this line, of course, is going to go up 1 unit. 1, 2, 3, 4 units over 4 units. So that's the slope of that line. So yeah, this equation looks exactly like that, fits that data. Okay, now, maybe this line does a good job. What I'm noticing here is that we have 1, 2, 3 data points above it and 4 below it. And these 4 look pretty far away from the line. This one's pretty far away, but these 2 are not. But these 4 below it look far away. So I'm going to say that this line doesn't quite fit the data. It's actually a little bit lower than that. So let's try some different points here and see what the equation looks like. So now let's look at 7.5. 7.5 is right here. And 14.8. 14.8 is this point there. Okay, draw a line between those 2 points. Looks like it goes through 2, but I'm not sure if it does or not. Let's go ahead and solve for it. So I'll name this one x2, y2 now, x1, y1, just to show you it doesn't matter which one's which. So m is y2 minus y1, x2 minus x1. 5 minus 8 is -3. 7 minus 14 is -7. That's going to be positive 3/7. Okay, y minus y1 is 8 equals 3/7. X minus x1 is 14. Distribute that. We're going to get y minus 8 equals 3/7 x. 7 and the 14 reduced to 2. 3 times 2 is 6. Right? Yes. Plus 8. And we get y equals 3/7 x plus 2. So I was correct in saying that this was what the y-intercept is, 2. And the slope is 3/7. So between these 2 points, let's see, it's over here, and go straight down. Go from 5, you go up 1, up 2, up 3 units. There we go. Let's see, we have 1, 2, 3, 4, 5, 6, 7 units. So yeah, that is a correct slope, 3/7. Now, is this trend line better to the data? We look at it, well, once again, we have this kind of problem. We have 3 points below it, 4 points above. This one's pretty far away. These two are a decent distance away. These ones look to be a little bit closer in my mind. Maybe that's a better estimate. I don't know. But the way you can really use this is ask the question, which line fits the best? Well, statisticians use what's called linear regression. It's this idea of what I was kind of looking at before, where you find the line. These are what are called residuals. It's the distance between each point that's not on the line. And you're finding the line that has the smallest total distance between each point. And that's, again, the topic called linear regression. If you want to look into that, look it up, and you can find some mathematical equations and things that they use for that. Okay, slope is an average change. And if you have a function and you want to find the average change over a certain period, so this could be any kind of function, not a linear function, but any kind of function, and you're asking what's the average change for this period of time, all we have to really do is use the slope formula. And since we know that y equals f of x, that means if you plug in x2 into here, y2 is going to be f of x2, and y1 is going to be f of x1. So that's all I've done here. I've changed y2 into that, and then y1 into that. And this is what we can use to find the average change. So for this function, we're looking, this is the equation of this function. All we're trying to do is figure out what's the average change over 2 to 8. Now 2 is right here, 8 is right here. So f of 2 is going to be, I think, somewhere around here. And f of 8 is going to be somewhere, I believe it's up here somewhere. And we're asking what's the average rate of change. That is the same thing as what is the slope of this line. If I can draw straight here. What's the slope? Well, all we have to do is find the rise over run. You couldn't actually find that here, right? It's going to be 2 to 8, 6. We don't know what the heights are, though. We can estimate it using the graph, but let's find actual values. So all we need to know is what is the function values at these points, right? I said f of x2 and f of x1. So this is x1, this is x2. F of x1 is going to be x1's 2, so plug 2 into here. 2 minus 1, 2 minus 5, 2 minus 7. It's going to give us 1 times negative 3 times negative 5, which is positive 15. Let's see, this is 12, 14, 15. That looks about right. And then f of x2, 8. Plug 8 into there. 8 minus 1, 8 minus 5, 8 minus 7. 7 times 3 times 1, that is 21. So 8 is at 21. I think I was a little bit high. Or no, that was about right. Yeah, I think it's at 21. So the rise over run then, it's going to be, the slope of this line is going to be f of x2 minus f of x1 over x2 minus x1. It's going to be 21 minus 15 over 8 minus 2, which is 6 over 6, or 1. So this is actually a slope of 1. So it rises 1 unit, it runs 1 unit. Rises 1 unit, runs 1 unit. This is a slope of 6 over 6. So the average rate of change of this thing is just 1. It just goes up over 1, up 1, and that's really all there is to it. Try it at number 4. Okay, now we're going to take this, what we just looked at, and we looked at between 2 and 8. And I'm going to rewrite 8 as 2 plus 6. This is going to be important for this next way I write this thing. And so this is what we had, f of 8 minus f of 2 over 8 minus 2. That's what we just showed. But now I'm going to write it as f of 6 plus 2 instead of 8, 6 plus 2. And instead of 8 here, I'm going to write it as 6 plus 2. What this gives us is now f of 6 plus 2 minus f of 2 over, well, 6 plus 2 minus 2, that's the same thing as just 6. And I've written this instead of looking at the final minus the initial, I looked at the distance between the final and the initial, which is 6. And I've only used the initial value and the distance from the initial value. Typically, this will be written as h. So we have it, the initial value is 2. I'm going to write it like this, 2 plus h. I'm just changing 6 to h and flipping it around. Minus f of 2 over h. So, of course, h is 6 here. And this formula is what we're looking at, what we're kind of studying here. So over the general interval here, x1, x2, where x2 equals x1 plus some distance h, then I can rewrite this as just x plus h, just like I did up here, as 8 is 6 plus 2, x2 is x1 plus h, the distance from x1. And then this one becomes f of x1 plus h minus f of x1. x1 and x1 cancel, and you only get h on bottom. Now, it's important to know that h is some greater than 0 number here. Of course, we're not looking at a division by 0. And we will replace x1 with just x so that you get the general form. And this is called the difference quotient. It's, again, a little bit weird when you're not understanding why we're doing this, but this is an important idea. The difference quotient is just this formula here. H is some number that's non-zero. If it were 0, then you'd have a division by 0, and that can't happen. But we have some function, some starting value x, and then some distance from x. Now, in general, we don't state what x and h are. We just leave them as x and h, and we work with the function. But I just want to show you this thing on a graph here. So this is some function, and we have this starting point is x, and the distance from x to the next point is going to be h. And all I've done here is I've created a y value for this first point is this y value here, which just happens to be at 215. And this second value is also this point here. And then as I increase this thing, you can see that I'm increasing this, and the slope of this line changes. So really, it's the same thing that I showed before. It's this average rate of change between this point and this point, but now instead of using this point's coordinates, we're using the distance between the first point as in our formula. So that's really all we're doing here. We're just looking at what's the change over this period. And then as h gets closer and closer and closer, it then shifts over to being that way, but you really wouldn't have that. You just move this point back. Okay. So once again, the importance of this thing is not really clear right now, but it is important in calculus. In fact, it's important for the definition of derivatives, one of the basic beginning topics that you're going to use all throughout calculus. It's incredibly important for the definition of that. And when you're looking at, in general, a difference quotient of something, so of some function, the goal is to just plug in the function and then cancel out the bottom h. If you can do that, you've achieved what you're trying to do. So what's the difference quotient of this function here? Well, the difference quotient is this: f of x plus h minus f of x over h. Okay, we know what f of x is. This, of course, is just the function. F of x plus h, well, that means we have to plug in x plus h into this function. So f of x plus h is 1/8 x plus h plus 7. Distribute the 1/8. And that is f of x plus h. So that just goes there. Of course, h stays the same. So let's go ahead and evaluate this thing. So f of x plus h is f of x over h equals x plus h is this: 1/8 x plus 1/8 h plus 7 minus f of x, which is just that, 1/8 x plus 7. You can see I put that in parentheses because I need to distribute the negative all over h. Okay, distributing the negative gives me this statement. And now I can combine like terms. The 1/8 and the 1/8 cancel, plus 7 minus 7 cancel, and we get 1/8 h over h. And at this point you can see, well, we can just cancel out the h. And this difference quotient is just 1/8. Okay, give it a try in number 5.